to get a better feel for polymorphism, I want to go through an activity here that's going to have us do some design. As I said, this is not directly tying into the discussion board or the individual project, but I think for you to have a feel for polymorphism and what value it creates, and also something we don't get a lot of time to do here is design. I want to spend a little bit of time basically looking at a problem and how we could tie in from concept to the details of using inheritance, using polymorphism, using behavior like that. So the first thing we need to do is understand the domain of any problem that we want to model. Now, when we talk about object-oriented stuff, it is a coding technique, and we're learning it in a Java class, but it's also a modeling technique. It's a way of understanding the world, because our code fundamentally represents behaviors that we want to emulate from the real world, or behaviors we want to model in a way that impacts the real world. So by using this modeling technique, it helps us describe the real world and know that our code is going to align well to how it's going to be used. So we're going to find sources of information, we're going to get write-ups, we're going to get analysis, we're going to look for information from that. You'll learn more about this if and when you take a requirements class someday. There's a decent requirements class here. You'll go learn more about this. You'll learn more about use cases and writing formal requirements, things like that. But sometimes as a coder, we just have to do this. We have to go and figure out information. We're not always given, go build exactly this way for us. Sometimes we got to go figure it out on our own. So when we figure out the space of what we're going to do, we need to pick a scope of what we're going to start modeling, and then the problem we're going to try and solve within that model. Because most applications aren't that simple that you can draw one model and have it represent everything. Think right now, if you're going to draw a picture of your house, could you draw a singular picture to represent every detail of your house? I mean, most buildings have at least two pictures. You have a landscape, which is, as if you were standing in front of your house taking a picture of it, but drawing it up. And then you have a floor plan, which is standing above your house and taking a picture, drawing up the floor plan. And that really only works well in a ranch house and doesn't show you what the backyard looks like. So realistically, you're going to have a floor plan for each floor, for each level, and then probably a elevation for each north to south, east, west of it, and then possibly additional drawings to show you plumbing and electrical and other elements that you might want to see inside of your building that you're going to build. And so in software, it's no different. I can't draw a single picture and represent every aspect of a website or a GUI application or whatever I want to build. So I'm going to have many scopes, many contexts, and I got to pick one of them I want to go off and model. So for this exercise, we need a domain. I'm calling it my home awareness system. So you can think of it as a smart house, but I want to do more than just what's the temperature on the wall. I want to be able to both measure my house and respond to some of those conditions in kind of a durable little pathway. There's systems like this that exist, and I think it's hopefully something that's pertinent and relevant and something we can build on as a nice little example. So this is a more detailed write-up. What I'm going to ask you to do is to pause the video at this point and read this write-up, and then we'll continue from there. But instead of me sitting there reading it to you in video, I'll just pause it, read it up. Hopefully it pauses nice and crisp for you, and then we'll continue from there. Okay, you've paused it, you've read it, or if you didn't, quick pause again. Okay, yeah, definitely by now you've paused it and read it. So we're going to continue on. There's a lot of good info inside of there. And typically we'd have pages and pages and pages of info, or big long conversations, or something in there. And so we need to know what's important stuff there. We need to pick out the key words that represent things. And I want to be specific, the key words in that document. I don't want to go define a new vocabulary for this. However your customer refers to these pieces in the system, if you can model your software to also call them the same thing, it's going to be easier to communicate with them. You can learn to think the way they think about their system. You can show them your diagrams and they will understand at least parts of it because you're using the same words for them. And so we need to pick out what are the key words instead of there. There's a lot of fluffy words in English. So we want to skip by all the fluff and all the description and get the context inside of there and pick what are the most important words to start working from. So in that activity, we can look at the write-up we had last time, and basically what I've done is bolded and underlined it, or maybe just underlined and de-emphasize the other words, to kind of go and pick the most interesting words or word phrases. And they're largely around the nouns. You can see the system. What system? The home security system. Window and door and alarms. Smoke and CO2 alarms. Different types of alarms that are out there. Sensors. In this case, specifically a temperature sensor, and again, another alarm. We want to be able to control the temperature. There's, that's an action we're going to be going off and take. You can see there's something about plugins and monitor data and sensors and multiple monitors. It's not everything that's inside there. I need some context, but this is a collection of largely nouns that's going to lead me to the different objects that are going to live in my system. So those words are starting to bleed into what my code's going to be structured in, because they tell me what's important in the domain and what are the important actions that are in the domain. The objects are going to provide value inside of there. Now, if we were teaching a class on object-oriented analysis, we'd talk about how do I go and figure out what are objects and what are classes and group them up and figure out the attributes and a lot of that different stuff. It's good stuff to be able to do. We're going to go off and do a little bit of that here, but I'm going to skip through a lot of it to say here's a much longer write-up and here's much more interesting objects and actions that I get out of that. So in our system, we're going to be tracking temperature and humidity and smoke level and CO2, and again, you can pause and look at the list in more detail. We want to be able to have alarms that go off. We want to be able to adjust the living environment. So if I have plants in a room, I can customize the humidity, temperature, and light in that room based off of what plants are in there. So I could have a really smart app that says, I'm growing cacti in here, so make it hot and dry. I'm growing tropical plants in here, make it wet and humid, and whatever other plants you might be growing there. So that's the type of things my system would do. It's a lot. I mean, again, we're not in the next 5 minutes going to model out a system that does all these things. So what we need to do is we need to focus. There's a ton of features. There's a ton of behaviors. There's a ton of things I could go off and build here, but I don't have time for them all. I need to basically get into a specific context. I need to be able to go through and pick which problem am I going to start to solve, what drawings am I going to make to solve those problems. And it doesn't matter at this point which one I do. The way I would be choosing this is probably what's most important to my customer. What's the thing they want to do most? Or pending, they say everything and you got a year to go do that, then I would probably take some, we'll call it low-hanging fruit, things that are easy to implement, or maybe things that are particularly challenging that would be foundational towards solving other problems. You don't always build everything easy and leave the hard stuff till the end, because then you can fall apart because you can't solve the hard stuff. So you strategize. That's where experience will come in later on. You'll pick which things to go on, but we're going to focus in all from this whole list of everything that was over there. We're not going to do all this. We're going to focus into one of these two problems we can identify at this point. We're going to start with just one of them. So one of the problems, what's the status of a room? Okay, but it's one of the problems we're going to try to solve. And the objects that are related to that is the sensors and the monitors. We could also talk about modifying the state of the room. Again, making it more humid, making it hotter, making it colder. Related objects there is the controllers that would change that and the devices that would be involved. And then these two things, you can see they're two related problems. I need to know the status in order to know what to modify it. And so it's a nice set of problems to figure out. It's a nice set of problems to work with. And then I can figure out which classes I need to pull in, the objects and classes I need to pull in, and which ones I can leave out of the picture for now. So if I solve the status of the room, I need to say, okay, the sensors give me information, the monitors analyze that information. Then from there, I could say, let's modify it. So let's say I have a fire detection system, and I determine the house is on fire. I can throw over the window to say, okay, put the fire out. At which point the controllers kick on, they turn on the sprinklers, they turn off the air conditioning system, they alert the fire, whatever different things. They set off the noise that would be happening associated with that. Get out of the house, it's on fire. We can hopefully now see we can break up our problem into pieces and then solve those pieces from here. So in the sake of just giving you a mental break, let me pause here. We'll flip over to another video. We'll come back here in a second, but I want you to maybe go back, maybe look at that list of things and see how from that whole list of things I can simplify it down by breaking up my problem. breaking up into chunks. I don't need to solve a whole system. I need to solve problems within the system. And I can then align those problems as I solve knowing the room status, then I can go modify the state of the room. So again, I want you to take a moment and reflect on where we started, that big problem statement. Maybe just, you don't have to watch the whole video again, but maybe skip through it, read some of those things, and then come back to what we're seeing now. Wow, I've simplified it down. I found some context inside of here, and then I've figured out what I want to drill in and get some more details on. I'm not trying to solve what does all sensors look like in the whole system. I'm trying to solve, for knowing a room status, how do I define a sensor and a monitor? What are the things that I need to define? All right, so go off and do that. Consider that, and then we'll drill down. We'll drill into one of these problems. We're going to drill into problem one and try and figure out what do we do to model this out. And then next step is, how does inheritance fall into this, or the other options we could do for design as well. That's what we're trying to look at, is where does inheritance fit into your work as a designer and a coder.